is keeping track of is just watching my YouTube videos, then they will have missed this. And I think what I should do is freeze this and use this camera. Because otherwise they can't see anything. So there are three things that I want to get across here, three hints. This is like a mini extended problem. And your homework tonight is to do a couple of extended kinematics problems. And all that means is it's just one big long scenario that's got several things going on in it. You know, there might be something accelerating at the beginning, and then the acceleration stops, and then it hits something, and that causes the new acceleration. So there are different things happening at different times, and you have to figure out one event before you can use that as a starting point for the next event. And this is kind of the same thing. So get out a sheet of paper or something, or I guess you don't really have to, but I would recommend getting out a sheet of paper and trying to keep up with me on this. And I'm going to do three things. I'm going to draw a diagram. I'm going to identify some separate events that are really part of this. And then I'm going to list some commonly used variables. And I think all three of these are tricks that help people. The diagram is super important, and so few students actually draw any diagrams on their tests, especially the ones who get things wrong. They usually don't draw anything. So I think I'll do a diagram first, and then I'm going to erase this. Sorry if you're looking at this and it's kind of washed out, but I think you can still read it. So get a ball. It's released from rest above a couch. Could be right here. The couch could be down there. After free falling for 4 seconds, the ball contacts the couch. So it's clearly I have to hold the ball much higher in order for it to free fall for 4 seconds before hitting the couch. If I dropped one from here, it would hit the couch in less than a second. And then it travels another 2 meters downward before coming to a stop. What's the ball's acceleration while it's being stopped by the couch cushion? So this, and pretty soon I'm going to get rid of this image, and then I can just draw and write stuff. So this is the beginning. I'll go ahead and label some variables. V0 is 0 meters per second. It's dropped from rest, and then it's free falling right here. Falls faster and faster and faster. This is not to scale. Right here, it hits the couch cushion. This is the cushion. So let's see. Contacts, cushion. I don't really need that label in there. I'm just doing it to be extra clear. And then it doesn't stop moving. It keeps on moving a little farther until it stops. And when it does that, the cushion just sort of deforms like this. So this distance from there to there is given. It's 0.2 meters. That's how far it travels between when it first contacts the cushion until it comes to rest. And this velocity is 0 because it's come to rest. So it's falling, it's going faster and faster and faster, and I'm just going to write in here free fall. And that means something very specific. It means there's no air resistance, and the only force acting on this is gravity. And I'll also write delta t equals 4 seconds. And I think that's everything that's given in the question. So I can get rid of this other stuff now. But first, I want to just draw a diagram, identify separate events, and then list some commonly used variables. So here's my drawing, and what I'm trying to find in the very end is I want to know for this final time interval, right in here, what's the acceleration? Let me move my camera a little bit. So the thing I want to do right now is to identify some different time periods in here. This is all one event. It's falling and it's coming to rest, but there are different accelerations in here. So from here until a certain point, the acceleration is the same. Tell me when the acceleration starts to change?
Yeah.
Right there, as soon as it touches this. So if I were to call this event 1 and event 2, people see? Number 1 is the free fall. And when it's free falling, the acceleration is negative 9.8 meters per second squared. And then, so it's going to go faster and faster and faster until right here. And then tell me when the acceleration, well, I'm not even going to ask you that. Then it gets a new acceleration until it stops. And here the acceleration's downward. As it's coming to a stop, is the acceleration still downward? Right here, is the acceleration down or up as it moves from here to there?
Down.
The movement's down, but is it speeding up or slowing down? Slowing down. So if you're going down and you're slowing down, then you're actually accelerating upward. So it's, in the beginning, this is going down and accelerating down, so it gets faster. Here it's going to be going down, but now accelerating upward, so it's getting slower. So event number 2 is being, I'll just say, accelerated upward by the couch cushion. And those are really, this is not an extended kinematics problem. This is just a little sort of a double problem. And in order to get to here, in order to figure out what that acceleration is that's due to the force of the couch cushion slowing it down, I've got to do 2 problems. Basically, I've got to do a problem here and a problem there. So 2 of my 3 hints are draw a diagram, label all kinds of stuff, try to identify time periods in here when different kinds of things are happening. And then the third one is to list some common variables. So these are just variables that show up in problems again and again. So for the free fall part, I want to see how much I know of all this. Initial velocity, acceleration, time, and since it's vertical, I want to do delta y. And then for the, try to separate this out. For the impact part, I want to do the same thing. V0, V, A, T, delta y. And I can just use what I'm given here and all my 6 formulas to start filling in this stuff until eventually I get this. This is what I'm looking for in the end. So I'm going to just start filling stuff in. For the free fall part, what's V0? Whoops. 0. What's V? Do I know? So V0 would be that. For this first part, the moment when it's right here, that would be when it has its final velocity. I don't know that, so can't fill that in. Do I know the acceleration during free fall? Negative 9.8 meters per second squared. And do I know the time period for free fall? 4 seconds. And do I know how far it fell? No. So don't know that. I'll just go ahead and do the second part too, because really, if it's possible I don't even need the first part. I'll go ahead and tell you, we're going to need the first part, but it's possible I could just use this bit of information at the end, and that would give me enough to find the acceleration due to the couch cushion. Do I know the initial velocity when it first hits the couch cushion?
No.
That's the acceleration as it falls, but we don't know what that is. We can figure that out pretty easily, but we don't know it right away. But what do I know about the initial velocity during the impact period? It's the same as what else?
The final velocity.
Yeah, so these 2 things, these are the same. So if I want that, I could go back and find this, and then that would give me that, and then I could move on from there. What about the final velocity here? Do I have that? Zero. The acceleration, I clearly don't know. That's what I'm looking for. Do I know the time period from when it hits there until it stops? Nope, don't know that. Do I know delta y?
Yes.
Yeah. So what would it, be careful, what should I write? The displacement, not the distance.
Negative.
Negative 0.2. And that's not going to be huge, but as you're doing this, if you don't put the negative in there, it could cause you big problems, and it might just, you get the wrong sign in the end, and you think, I'll just switch it, because I know it's supposed to be positive. But sometimes you can get the total wrong answer because of that. All right. So what I want to get is I want to get this. And based on what I've given here, I've got velocity, I've got displacement, I want acceleration. This is when it's good to have the formulas in your head, so you can kind of scroll through those and think, what formula has displacement and velocity and acceleration? Is there any formula with just those three? I'm going to write some formulas over here. Tell me when I get to one that you think might be useful. These are all the formulas that we've been over. Average velocity, in this case, would be delta y over t. Average velocity is also v plus v0 over 2. Acceleration is delta v over delta t. I'm just going to call it over t. Then there's velocity. Final velocity equals v0 plus at. There's displacement, delta y. Sorry if I'm in your way. Sit down. What's that?
V equals V0 plus
Yeah, that's going to be helpful right there. Delta y equals v0 t plus 1/2 at squared. And then the last one, v squared equals v0 squared plus 2a delta y. So you're thinking this is helpful? So what can we do with that here?
We can solve for the final velocity for free fall.
Right, so that formula we could use here to get this initial velocity, and that initial velocity will then give us, wait a second, we need to go the other way. Yeah, so we need to use that here to get that, and then we can say that's the same as that, and then we can do some more stuff there. Okay, so I'll go ahead and do that. I'm using v equals v0 plus at. I'll just write it again. And I'm plugging in, v0 is 0. A is negative 9.8. And the time is 4 seconds. You can kind of do this in your head. If it's accelerating by that every second, and you do that for 4 seconds, you just do negative 9.8 plus another negative 9.8 plus another negative 9.8. And that's going to give us final velocity equals 4 times 9.8, which would be 39.2, negative 39.2 meters per second. So now we've got this. So now we've got, for the impact part, we've got the initial velocity, we've got the final velocity, we've got the displacement. Does anybody see a formula over here that can get us acceleration if we have initial and final velocity and displacement? Yeah.
So v squared equals v0 squared.
When you have displacement, I guess there are 3 formulas that can be helpful, but usually when there's some acceleration in displacement, it's either going to be this one or this one. If you've got time and displacement, this is the one you got to go with. If you have distance, sorry, if you don't have time, it's got to be that one. And this only works if there's no acceleration. Yeah, Tom.
Displacement, delta y and delta x.
Yeah.
Interchangeable.
So, right, I'm using delta y because now we're in this dimension, we're going up and down. And
What is delta x?
yeah, so we're in the y dimension on a graph, I use delta y, and if we were going this way, I'd call it delta x. So all this in physics, all this lives on a graph. You know, here's the y-axis and the x-axis. And this is just moving up and down in the y-axis. So I'll use this space right here to wrap this up. The v squared equals v0 squared plus 2a delta y in this case. So v squared, v is 0, so that's 0 squared. v0 is negative 39.2. Square that, plus 2 times the acceleration, which I don't know, and then delta y is negative 0.2. So if you don't have that negative in there, then what you're going to wind up with is a positive acceleration. And I think most people would say, oh, I've got my answer, and you'd be right. But wait a second. No, you'd end up with a negative acceleration. Let me just finish this. 39.2, has anybody squared it? Is anybody doing calculations out there? I can't remember what the answer is.
1,536.
So it's 1,537-ish. Meters squared per second squared. And this would be 2 times that is negative 0.4 meters times A. So if I add this to both sides, I get 1537 equals negative 0.4 meters times A. So I just need to divide that by 0.4.
Wouldn't
So the acceleration
137 be negative?
is
Mr. Stapleton?
negative 3,841 meters per second squared. Wait a second. Positive. This should be negative. This should be negative. Sorry. Thank you. Screwing that up myself. That seems really fast. Did I screw up somewhere there? I guess it's just probably an unlikely distance. I don't know. Something seems fishy about that. I'm curious to look back at my notes from, let's do that. So I can switch, or I can look at my old answer key to my notes before, and let's see if I got the same thing. Oh yeah, here it is. Oh, but the people in here need to see it too. Oh! I forgot the last part. Shame on me there. So, or did I?
I don't know, you have that 3,142.
Oh yeah, never mind. Okay, sorry. I was thinking I needed to take the square root of it. Somebody was just asking if you could have what? This paper?
No, like you forgot to give us in your brother, you took notes on yesterday.
Yes. I'll give you that. If I can't give it to you now, can I give it to you in a little while?
Yeah.
Okay. All right. So let me go back to